be dealing with other types of quadrilaterals. So today's the last real day of notes because then down the road we're going to talk about what's next. So here we go. So the rhombus, square, trapezoid, kites. We're going to talk a little bit about each of these types of items. So the first thing we're going to talk about, the rhombus. It looks like a parallelogram, but it also looks like a square. It's like the parallelogram in that, oh, I cannot draw it. I can't draw it on that, but kind of looks like a parallelogram in the sense it's slanted. However, it's like a square. Okay, ladies in the back, that conversation, is it related to what's going on in this classroom? And if it is, let us know. If it's not, you need to end it. The end. So again, rhombus. Oops. Let me take that back a little. So it kind of looks like a parallelogram. It kind of looks like a square. The only difference, I'm not going to ask again. I asked one more time, you two are getting separated at the end. But you don't have to worry about this. All right. Rules are the following. Opposite sides congruent. Parallel, that means they'll never touch. Opposite angles are congruent. So this angle is congruent to that one. Consecutive angles are supplementary. That means they add up to 180. Do we remember that?
Yes.
Okay. Also your diagonals. Boom. They bisect each other. So this diagonal, when it crosses the other, they act like bisectors. So this length here, same as that length. That length is the same as that length. So that one, we should know about that for a while now. Let me make that. That did not work. Anyway, now, rhombus. The outer sides are congruent. That means all four of these sides, boom, boom. So like a square, all congruent. Diagonals are perpendicular. So if it's perpendicular, what type of angle do we have at this intersection? Anytime you see a little box, that's what type of angle? 90-degree angle. That's a right angle. Also, the diagonals bisect these outer angles, the opposite angles. So when it's bisecting, that means, let's say if this angle is, I don't know, 30 degrees. I'm just going to make up a number. Then this other angle must also be how many degrees?
30.
Just 30. So that means the diagonals bisect the opposite angles. That means these two angles are going to be the same. Now, the diagonals are not always necessarily congruent in the rhombus. So we'll talk about a couple things. All right, questions before we start. And these are going to be rules we're going to be dealing with all day today. All right, here we go. Now, I'm just going to do a couple here and there. So, they gave us JK was 12. And then they said J to N. From here to there was 7. All right. So, J to M. So here's J, there's M. Well, the rhombus, they said all the outside sides were what? We just said it, like a square. All four sides are congruent. So JK, if that's 12, then JM must also be. JM is 12. Now, notice they said JN was 7. But JL goes all the way down. But what did we say about the midpoint? What did we say? Well, the angles are 90, yeah, but what else? What's that? Oh, okay. Okay, hold on. Different one? Oh, it's not working? Oh. Oh. All right, hold on. I'll take care of that. Yup. All right, I fixed that problem. But yeah, J to L all the way down is 14. That's your grand total because J to N is 7, but N to L has to also be 7. So 7 plus 7 is 14. Now, what we could have done, I'm not going to bring these guys into the game, but the missing side, there is a way you can get that missing side. I'm not gonna go over it. Oh, that did not work. Hold on, I got a better idea. Just gonna show you really quick. You know what? That might work. All right, here we go. I really wanted to invert this triangle so you could see it a little better. All right, I'm taking this part over here. I'm going to show you. You know how we're the J, M, N, right? Now they said that this angle right here was a right angle, yeah? So what is always across on the right angle? What's that called? Hypotenuse. So this hypotenuse is 12. And then they said this distance from J to N was 7. So is there a way you could find that other side? Yeah, you can. That's a Pythagorean theorem. Now, we're not going to deal with it on this test. You're not going to have to know it, per se. But you might. That's actually a B, lowercase b. But you may have to use it down the road. So, for instance, so yeah, to get that last side, MN, use the Pythagorean theorem. But we're not going to go into that. So yeah, so we got to find the MN. But I'm not going to waste time. Use Pythagorean theorem. But it's just more for you. And you're not required to find MN or MK. But again, this relationship, halfway, it's our way. So don't worry about it, but I'm just letting you know. I don't think you're going to get this question on this test. It's actually going to be fourth quarter because we just ran out of time for the quarter. And So it's going to be fourth quarter's the test. We'll talk about when this Unit 7 test is going to be after the break. It's more than likely, because I know there's going to be a calendar and everything. It gets a little weird. So it's probably going to be not the first week you get back from the break, but I think the following week. So, but during that time when we get back from break, we're going to review. And then we'll talk about something else as well. All right. Questions before we continue? So that's really all you need to know for the sides for now. Outside sides are the same. Diagonals are bisected right in the middle. Whatever's the length of this side, the other side's that length. If you need to find that third side, it's Pythagorean theorem, but I'm not going to hold you up to it. You're not going to be required. All right, questions before we move on. Because the next slide's the slide I want you to worry about. Next couple. Here we go. The next slide, get ready. The one where you see all them angle measures. But I'm going to tell you, this is actually much easier than you think. You're probably saying, oh my goodness, I got to get all 8 of these angles. It's not as bad as you think. And I'm going to tell you something else. We said it right off the top. 2 things happen. Well, your diagonals act like bisectors. That means it splits everything in the head equally. So basically, each side is a mirror of the other. Also, don't forget, if these sides are parallel up here, you also have something called alternate interior angles. So that's going to help you get, right away, this diagram, we're going to get angle 3, 4, 5. But you also know something else. Right in the middle. What type of angle is formed here, 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 and there? What type of angle was formed? 90. So right away, angle 8 is how many degrees? Boom. Let me write that. I'll type it in. Yeah, angle 8 right away is 90 degrees. Now, we also said diagonals bisect each other. So if this angle is 38, then angle 3 must also be how many degrees?
38.
That's also going to be 38. So if angle 3 is 38, now we also know that 4 and 5 are also going to be how many degrees? Because you got that alternate interior. 3 and 5 are alternate interior angles. And angle 4 is an alternate interior to that 38 degrees. So there you go. 38. 38. 38. And right here, these are all 90s. I'm not even going to mark them. But all these angles are 90 degrees apiece. I'm just going to put a 90 right in the middle. So you know that 90, 90, 90, 90. Now, that's right. How'd you get the 52? Mm-hmm. Yup, that's all you had to do. You got that right, Des. There you go. 52. Remember, the sum of these angles, 52, 38, and 90, have to add up to 180. You already have 90. You have another 38. So that's 128. So 180 minus 128, 52. Boom. There you go. So all them other, so 1, 2, 7, and 6 are all going to be 52-degree angles. So really, $52, $52, and then down here, $52, $52. Boom. There you go. That wasn't bad, right? Once we knew one, we knew all the others. You know a lot more than you think. I'm going to make this 38 a little darker for angle 5. But yeah, angle 3, 38 because that diagonal bisects. This angle right here is 90 because it's a right angle. So then the last one is 180 minus 126. Or you could even say 90 minus 38. Because you already have 90. The other two have to add up to 90 as well. There you go. That's all you need to do for that problem. All right. Any questions on this problem? It's all them angles. So if you haven't done so, write that information down. But this one I would highlight because chances are you may see something like this on your test. The angles, especially for these problems, are going to be real easy. All right, ready for the next one. Now we're going to go back to the side for the moment. All right, this one. So it should be on the next page. You should have this slide. I think I updated it. Okay, it is a correct one because I had another one, but it wasn't going to work. So you know it's not on your paper. All 4 sides are the same. So if we want to solve for this variable, what do we have to do with these 2 sides? All 4 sides have the same length. So what do we know about the relationship between PS and SR? There you go. So it's 2y. Oh, something out. Two y plus 3 equals 5y minus 6. Now we at a point where we can solve for y. Can we solve for y? All right, I want y'all to do that real quick. Then I'm just going to ask for an answer for y. First, you got to get y first. I'm going to say first solve for y. So that should only take you 2 to 3 steps. And then once you get that value y, substitute into plus 3. And then 5y minus 6. And then, well, once you actually just get the first one, what do we know about all four sides? All four sides are the same. So basically, once you get the first one, you basically have all four sides. Remember, you have to solve for y first, but you're not finished after you solve for y. Okay, we agree? 3 for y? Okay, so y is 3. I agree too. So substitute y equals 3. Into 2y plus 3, 5y minus 6, and then what do we get in both cases? Both are going to be 9. And if they're both 9, that means the other two sides also have to be 9. I'll just leave it like that. So all your sides in the end are going to equal 9. Now at this point, I should not have to go over how we found y to equal 3. This juncture of the game, that should not need to be taught. You guys, you all know how to get there at this point. The purpose again is going from here, given this information, to here and there. Okay, questions before I continue? All right, next question. Now we're going to be working with angles again. All right. So highlighted, we said angle ZXY is 34 degrees. Do we have enough information to get all the other angles? We do. Well, because of the rhombus, what do we know? Okay, again, what do we know about the angle bisector here? What do we know about this? What about this diagonal? 90 degrees. Okay, here is 90. So all four of these are going to be 90. I'm just going to draw the right angle marker. 90, 90, 90, and 90. That's a 90-degree angle. If you want to put a 90 right in the middle, you can. Yeah. Any of these four angles work. Is 90 degrees. Now with the diagonal, that's also your bisector. Remember with the bisector, it's like looking into a, you can do the name, looking into a mirror. So basically everything on the other side that reflects, yeah, the bisector acts like a reflection. So this little angle here is 34. then what must this angle right here also equal? That's also going to be 34. Now, that's also going to be down here and here, 34. I'm just going to write the number 34 with arrows. In fact, I should have wrote that up here too. So we have a 34 and a 90. Now who could guess what other number we would have in any of these four triangles to give us the actual triangle? What must this angle measure? Here, here, there, or there. What must they're all going to be the same number, but there's only one possible number. What number would that be? About it like this. Here's your triangle. It's missing angle, the last one. It's going to be 56. For any of those four, it's all going to be 56. Because if this one in the middle is 90, this angle is 34. That last one has to be 56. And basically, everything's going to match. Because don't forget, this other diagonal right here, I'm going to highlight in blue, that's also going to act like a mirror. So you see 56 over here, you're going to see 56 over here. It's 34 here, 34 there. 34 here, there. But also you're going to see it here, here. So think about it like a mirror. Diagonals are like mirrors. Now, are we at a point where we can find all four of these angles? Yeah, you can. Well, first off, WXZ. You start at W. Go to X. And then from X, we go all the way down to Z. How many degrees is WXZ? Where we drew that green line. What number is between those two green lines? No. 34. W, X, Z. That's why I'm saying colored pencils might be a good idea. Now, W, V, Z. There's W. You make the turn right at the middle, and you go to Z. But if we make that turn right here, how many degrees is this angle right here? 90. That is definitely a 90. And then Z, go to Y, and then we shoot up to W. How many degrees was this angle right here? 56. And XYW is going to be the same. Does everybody see? You start at X, Y, shoot up to W. You see that's also going to be 56, right? Yeah, because I'll highlight that puppy for you. X to Y, and Y up to W. That's also going to be 56 right there. All right, questions, anybody? So what I would do, anytime you get these types of problems, put all the angle measures in right away. Because once you put in all the angle measures, then when you get to this part of the question, you just follow the math. Start at W, boom, go to X, shoot down to Z. Look at the number between. Similarly, Z to Y to W. Look at that number. Boom, there you go, you already have it. So basically, it looks like a road map. I know it gets a little confusing, especially because the diagrams are not the biggest diagrams on the planet. But that's how we answer those 4 questions. So if you didn't get those numbers, you got to write them down, please. So basically with the rhombus, sides are congruent, diagonals bisect, they act like mirrors. And then when the diagonals do bisect each other, they form right angles. So those are the 3 most important things you need to know with a rhombus. The diagonals, they bisect each other at a 90-degree angle. Outside edges are congruent. The diagonals bisect each other at the midpoint. And then also diagonals bisect the outer angle. Again, think about that idea. The bisector, the angle bisector, or the segment bisector. Think about the mirror. Whatever's on one side, you see the reflection on the other. Anybody have any questions? All right. So similar to the rectangle, the rhombus rather, and you can say to the rectangle, are squares. Now this next slide is more information, but a lot of the information is the same. I'll make this a little bigger for everybody. Although it's probably right there, but with squares, opposite sides, congruent, parallel. Opposite angles, congruent. Consecutive angles, that means if you go up and down or right to left, supplementary. What do we mean by supplementary? You see the word supplementary? It means that they add up to what? Angles add up to? How many degrees? If it's supplementary. Okay, that's something we should know. We should know. The 2 supplementary angles, that means they add up to 180. That was a quarter 1 thing. Valerie, Zoe, we good with that part? Okay. Just want to make sure. Diagonals bisect. Diagonals in this case are congruent. They form 4 right angles, 4 congruent sides, perpendicular, bisect opposite angles. So basically with squares, everything's going to be basically congruent. Diagonals, perpendicular, congruent, bisect each other. Everything is going to be congruent. All right, any questions before we start? And with angles, 2 magic numbers. For angles, 90 or 45. With squares, the 2 magic numbers are 90 or 45. All right, are we ready? Catherine, you ready too? Here we go. All right, for this problem, okay, why does that look too small? Here we go. So we're right now dealing with diagonals because they said TR was 17. So say they said from T to R, 17. Now, so that's this inside part right here. Now, do we have enough information to also get? All right, because then if this part's 17, then what must each of these other parts also be? Like the ones inside. 34 is going to be the total. So that means if you have 17 here, then you must also have 17. 17. 17. Now, I crossed out the last one, PQ, because this was an outside edge, but you could still get PQ. I'll tell you in a second. But Catherine, you said something was 34.
34 is PR.
PR will be,
QS.
PR and QS are both going to be 34. She's right. Both of them are going to be 34. And then, of course, QT is going to be how much? 17. Now, if you wanted to get PQ, which I crossed out on up here, so you don't have to do it, but one of two ways. Again, 17, 17, even though we don't know it, because, well, we know that this is a right angle here, right? All four of these angles inside, right in that middle, are right angles, right? So that means if we just take one piece of the triangle, that means its outer edge must be the, begins with an H. That's going to be a hypotenuse. So if you wanted to get PQ, you'd have to do Pythagorean theorem. Now, am I going to require you to do that? No, not on this. So yeah, basically be 17 squared plus 17 squared is h squared. So, and then also with the square, they said that this was 90. If these sides were congruent, then these two angles must also be congruent. So that would be a 45 and a 45. That's the only way it's going to work. And actually, if anybody remembered, if we have a 45, 45, 90, what can we multiply 17 by to get the hypotenuse? Anybody remember? Square root of
3.
Close. 2. Yeah, that's a 45, 45, 90. So that's 17 square root of 2. But you don't have, again, you don't have to know it, but could you figure it out? You can. But I'm not going to go into it. Okay, questions? But again, you're not going to get something like that on the test. I'm not going to give it to you. But could you see it on a final? Maybe. Because you will have to take a final for the class. Zoe. Okay, just making sure you're awake. This is not sleepy time. All right. Questions before we continue? Okay. Now, remember what I said with angle measures for squares? There's only two possible numbers you have to worry about, 45 and 90. And I'll tell you how. Because if you're on the outside, if it's an outside angle, your angle's outside, then it's a 90. But that's 90 all the way around. But what is exactly half of 90? 45. So if you're on the outside, it's 90. Now, if you're in the middle here, don't forget, if you're in the middle, it's still a 90. That's still 90 right in the middle. But if it's one of these corners, then in all 1, 2, 3, 4, 5, 6, 7, 8 cases, if it's from here to here, then it will be how many degrees? If it's not 90, then it has to be, what's half of 90? 45. They're all going to be 45. Because remember, the diagonal bisects. That diagonal bisects that right angle into exactly two equal smaller angles. So in all these 8 cases, oops, it's going to be 45. And you can say the same there, there. I mean, you can fill it in here and here. So all 8 of these smaller angles are going to be 45. If it's an outer angle, it's 90. Or if it's a bisector right in the middle, it's 90. So let's check this out. First, we start at P. We go down to R. And then we turn towards S. How many degrees will this angle be? There's only one of two possible numbers. It's 45. If you're not a right angle, then you have to be 45 degrees. What about the next one? S, T, R. Start at S. Go to T. Then we go back down to R. How many degrees will this angle be? Look what is that angle right there? That's that box. How many degrees does that angle have to be? This angle right here. That has to be 90. Now, PSR, you got to be careful. P is here. You go down to S. But then you make a turn from S and you go to R. How many degrees is PSR? PSR. How many degrees? How many degrees is that angle? That's 90. And then last but not least, here's Q. Go to P. And P down to R. Is that a 90 or a 45? Is that a 90 or a 45 degree angle right here? P, all right, Q to P, down to R. Is that a 90 or a 45 right here? That's a 45. So inside here, smaller angle will be 45. So again, with these, with your squares, it's a right angle or it's 45. It's 90 or 45. Those are the only two numbers I better see. Anybody have any questions? All right. Are we good with 4B? Okay, next slide, 5A. Put a big fat X through it. Put an X. You're not doing it. That's it. As long as you put an X where I told you, good. That's it. We're not dealing with it. All right, this one's going to basically be the same. It's either 90 or 45. So if we start, we go from DAB. There's D, A, we turn to B. Is that a 90 or a 45? All right, what about AEB? Look where you're turning. That's 90. All right. What about CBD? That's a 45. And then what about BAC? BAC? That's also 45. So the first two are 90, the last two are 45. What did I tell everybody to do with slide 5A? Put a big fat X right through that slide. We're not doing it. So basically with squares, outer edges are congruent. You're either going to have a right angle of 90 degrees or it's a 45-degree angle. Those are the only two angle measures for squares. All right, are there any questions? Now, next thing we're going to talk about are the trapezoids. Now, with trapezoids, consecutive angles, depending on where you are, depending on what type of trapezoid you have. Now, the consecutive angles are supplementary, but that's mainly if you're going up and down. Going up and down, it's usually, now be careful. If your trapezoid looks like this, then then it's going to be more likely side to side. But most of them are going to look like this. Like these two angles would be supplementary. We went up and down. So with these two, but obviously with these two, you're going to see that they're both right angles. Here, similar. So, but a couple things with isosceles trapezoid, the two sides, the slanted sides are congruent. The diagonals are congruent. And these angles right here are also going to be congruent. And you could also say the opposite angles along with your consecutive, like going up and down, are going to be supplementary. Now, but going across, depending on what type of trapezoid you're dealing with, they're either going to be congruent. Now, some of them might not be, like right here, they're not going to be congruent. So you got to be careful. Okay. I should be aware, though, consecutive angles, usually it's going up and down. So I shouldn't always say going up and down because it could be side to side. So if you want to add, or depending on what it looks like, it could be right to left. Depends. You got to look at the problem, though, because these two, now, if it's like this, then it would be side to side. We'll just say left and right. Well, it should be both ways. Left and right, the arrow's going both directions. So it might look something like this. They add up to 180. Okay, anybody any questions? All right, so for the most part, on these types of problems, you're either going to be dealing with consecutive or congruent. Or I should say supplementary or congruent. That's what's going on for the majority of these problems. We're going to be dealing with majority of them with angles. All right, questions before we go on? All right, here we go. Okay, here's what we have going on. Up and down. So something plus something is 180. And then whatever's here plus this guy will also be 180. So we're going up and down. So first, this number right here, what do I add to 51 to get 180? You tell us. I'm going to figure out this number. Remember, these two numbers have to add up to 180. So what can we do with the 180 and the 51 to get this number? So it's 180 minus 51. So what would be 180 minus 51? Yup. $129. So angle K is 129. And then similarly, if I want to get angle M, what do I do? 180 minus what? What number? Is it going to be 51, 129, or 87? And then we should get 93. So angle M, 93. So far, any questions? So far, any questions on this one? Again, remember, these are graded notes, so if you have any blanks, you're not going to get full credit. I'll dock points. Just letting everybody know. All right, next one. Okay. Now, here, this is where it could be the right to left. The same idea. What must the sum of these two angles add up to be? There's your setup. So, setup's going to be 54 plus 8x plus 6 equals 180. But what do we have to do right away? Combine like terms. So what terms could we which is 54 and 6 gives us
60.
all right. So really we have 8x plus 6 equals 180.
Don't you mean 60?
Yes, I do. And then I want you all to find x. So there's your next. So Jason gave us your next step. So find x. So go from here. Combine like terms.
15.
Mm-hmm. Solve for x. And then somebody said it.
10 equals 15.
X is 15. Very good. All right. Do we have to do anything else for this problem? Because you just said solve for what? X. That's it. Now, anybody have any questions solving for x from given what we did? Combine line terms, solve for x. So you subtract 60 and then divide by 8. Minus 60. Then 8x divided by 15. I mean, 8x divided by, no, 120 divided by 8. I mean, we're at that point, we should not even have to go over this. Okay, questions on this one? All right, the next one. Well, since this is an isosceles trapezoid, you can split it right down the middle, like that. Boom, there's your reflection. So therefore, if angle P is 112, then angle Q must also be how many degrees? 112. So put 112 there. And then what about R and S? Well, what do we know going downwards? If we go down, somebody said it. It's going to be 68 in the end. Because going down, the sum has to be 180. Or depending on the direction, if it was, we did a quarter turn clockwise, then it would be going left to right. But I'm going to make it as fair as possible. So therefore, both angle R and angle S are going to be how many degrees? 68. That's all you had to do for that problem. Not too bad, right? Questions on that problem? So there's your numbers, 112, 68, 68. Again, consecutives going up and down. Not necessarily right to left. Isosceles, what you can do, just cut it right down the middle. And then you get basically one side's a reflection of the other. All right, questions on this problem? All right. Let's see if we're going to... All right, you know what? Just for this one, I'll just give you the setup. Try to solve on your own. I'm just going to give you the setup for this. Okay, here's what we know. The total is MP. Here's MP. Boom. NO. Boom. Well, what do we know about, if I could ever draw it right? Nope, strike two. What do we know about the lengths from MP, with MP and NO? What do we know about them? They're congruent. So, MP will equal NO. So basically, you're going to have 16x minus 13 equals 9x plus 8. Now, we also know they say Pn is this line here. MO is that line. What do we know about those two diagonals? They are, say again, they're the same too. Now, in both cases, you have enough information to solve for y. I'll just write reasons why they're the same. I'm just gonna I'm not gonna say more than what I'm gonna write up here because you have enough information to solve for the variable. But yeah, NP and NO, Non-parallel opposite sides are congruent. And then also, what about the diagonals? What do we know about the diagonals? The diagonals are also what? Diagonals are just like the non-parallel opposite sides. The diagonals are also congruent. We're going to be using more of these words. Especially when we start talking. Diagonals are congruent. I'm just letting you know why we're setting them equal to each other. But we're not going to do any more than this. This, you're going to try to solve on your own. I think x is going to be 3. Y will be 8. No, that's not right. No, that's wrong. X is going to be 1. No. 16 minus the next 7. 21. 40. Yeah, X should be 3. Okay, what am I thinking? Oh. Well, find out on your own. So I really want to talk about the last few things. Because I think what we're going to do, the last few, and this is actually going to be, if I say try to solve on your own, what you're going to do, when you come back, or this might be your first fourth quarter assignment. Once I give you the setup, solve. I'm gonna give you the setup, you solve. So that's gonna be, so what's good, here's what we'll do for today. Write down what I give you. You write down what I give you, you get credit for the class notes for today. But there are gonna be some problems. I'm gonna tell you, for your fourth quarter homework assignment, there's gonna be a few problems. If I say try to solve on your own, solve them on your own. That's going to be your first fourth quarter homework assignment. Not going to be a lot, but that's what we're going to do. All right. Anybody have any questions on this problem here? We'll see. Let's see how things go. All right. So what do we have for this problem? We want to find out what's the measure of angle C, angle B. Well, if we look, they gave us angle C. They also gave us angle D. So what would be the relationship between angle C and D?
They're both the same, so yeah. Yeah.
There's your setup. Try on your own. The problem 10. Again, we're not going to go over it. But now I'm only going to give you the setup.
So it's like plus 27 cos x minus 12.
And you have enough. You have enough information and knowledge to get this. And once you get your x, whatever your x value is, plug that number into here. So you get angle C equals something. Equals some number. But then what you do is to get angle B, whatever number you get for angle C, subtract from 180. That's how you're going to get angle B. Remember, C and B have to add up to 180. Do we agree? Okay, so that's what I'm telling you. So angle C plus angle B, I'll just write it here. Measure of angle B, angle C. That's why I'm breaking it down. Get that x value first. Once you get that x, find the value of angle C. Whatever number you get here, subtract it from 180. That's how you're going to get angle B. Anybody have any questions on that one? All right. 19, 20, and 21. Really quick. Okay.
I think this is equals 180.
They're going to add up to 180. That's right. So for problem 11, ten x minus 33 plus 4x plus 17 adds up to 180. That's your clue.
Would it be negative 33 plus 17?
Yup. So then, so then real quick, what's 10x and 4x gives us how many total x's? And then negative 33, positive 17. Combine those two terms, we get. Oh, watch your signs. Minus 16. Okay, so problem 11, that's all I'm going to tell you to do. Well, that's all I'm going to tell you to write down, but you got to get the rest. So, try on your own. I'm just giving you the connection. But now you have enough information to get your x and your two angles that are in question. So again, as long as you get up to what I have in red, that's all you need. The rest you can try on your own. But we will look at these next time. Like next time, like probably more than likely after the break, because I think I'm going to make this a fourth quarter grade again. All right. So these two. Okay, what must the sum of these two angles add up to be, since they're diagonal from each other? They're going to add up to 180. So for problem 12, ten x plus 5 plus 6x minus 1 add up to 180. Here's your clue. And basically, get your x, boom, plug it in. That's all I'm going to have you do. And then whatever you get for angle W, I'll help you find angle Y. So just again, try on your own. But you have enough information to start. I gave you the starting information, you know how to finish. And you're going to do that on your own. All right. Everybody get that one. Okay. And then for this last one, what do we know about the relationship between these two angles? Equal. Again, try on your own. And I'll just write it out real quick. This is your setup. They're equal. There's your setup. And then again, once you get your x, whatever value you get for x, plug it in. And then once you get whatever value here, subtract from 180. Boom, you get your last angle. All right, questions up to this point? Again, we will follow up with this after. If we don't follow it up next class, it will definitely be after our break. But if you get it done by next class, then you'll have your first quarter grade, fourth quarter grade. Now, the last thing I briefly want to mention with kites, I'm only going to mention one thing about them, maybe two. Basically, not the longer side, but the shorter like distance, those angles are going to be congruent. Now, where they meet, the diagonals are going to be perpendicular, but you're not even going to worry about it. Here's what only things I want to tell you. So listen up before we wrap it up. We're not done yet. Thing number one, right here. Now this one's going to be easy because these two angles going across are going to be congruent. So if angle L is 82, that means angle J is also angle J is going to be 82. Let me rewrite that. Now, angle K, you got to take the sum of all three of your angles. Add all three of them up, and then you're going to subtract from 360. So it's going to be 360 minus these three other angles. Is how many degrees? Yup. This angle K is going to be 360 minus 82 minus 82 minus 71. That's how you're going to get angle K. Now, you're going to put one more X somewhere. Questions on this one? So 82. You put that 125 in? Jason, we're not done yet. We're not done with that. We weren't done yet. Did you put 125 in for angle K? All right. You get to the last two slides real quick. Here's what you're going to do. Problem 15, put an X on it. You're not doing problem 15. Problem 15, X. Put a big fat X on it. Again, that's following directions. If you put the X where I tell you, that means you were listening. Last one. And again, when we go over this, because after the break, we're going to talk about this more. Last thing we're going to do, I'm just going to show you a setup. I'm going to do a try on your own. Here's your setup. Angle N and angle K are what to each other? They're congruent. Then it's 5x plus 23 equals 8x minus 31. And then you should, once you do that work, do your work, you get your value of x. And then, for angle L, just do your plug in. 5x 23, or 5, you fill in the parentheses, plus 23 equals whatever number. That's what you do. Take your X, plug it in. All right. So really quick. Good, good. Christian, take out your notes real quick. I want to see if you did them all. Good. All right, you got them? Okay. Okay, that's fine. Yeah. Wait a minute.
Oh, yeah. I'm definitely not starting to feel well. Oh, if
All right, you got your set up? Okay, that's fine.
I'm gonna tough it out.
Are you sure? Because I don't want.
Until I fall to the ground, I just like
There's
can't
notes,
move
I want to see what you have.
I want you to just pass out in the middle of the hall.
I've never passed that before, and I'm not gonna let it happen.
Good,
again.
good,
It's not.
good.
It's not pretty. It's really.
Dig in.
Trust me.
I'm not looking at
Okay.
I've seen like
All right.
2 people almost passed out.
All right, so you're gonna get credit for the
They
notes
were just like-
today.
uh,
Next class, heads up. Next class is a catch-up day. Catch-up.